we are in the part 3 of the video. Under part 2, I was trying to introduce a topic before I ended it. I said if this is a circle and this is the center of the circle, any line from the center of the circle to the circumference is the radius. And let me call it R. And from here to here, let me call this place theta and let me call this place X. And I said what we want to do here is we want to prove a formula that we'll be using throughout the course of this topic that I'm actually doing right now. And I said from here, this something I just wrote at the board, that theta is equals to S all over R. So theta here is equals to S all over R. Now, from here, remember, of course, this is angular. This is the angular distance. We talked about it. This is the linear distance. This is the radius. You see now? And so from here, I want to cross multiply. I want to make this sort of the formula. So X is equals to theta R. This is not Q but theta. So S is equals to theta R, right? Or let me say S is equals to R theta. Anyone. S is equals to R theta. Now let me call this equation 1. Now look at what I want to do. I want to differentiate with respect to t. If you do not know how to do differentiation, it's on my channel. Please watch the video. I want to differentiate with respect to t. So differentiating with respect to t, this is dx all over dt is equal to, this is radius, so it's a constant. Then you have r into the theta all over dt. Now, remember at the part 1, I've already done the whole intro. That's why I said if you miss part 1, as more as I'm going under this topic, you may find it confusing if you are not actually very good in this topic. So after differentiating, remember that velocity is distance all over time. Velocity is distance all over S all over t. Now look at it. So this changing this ds all over the t is v, because this is linear, right? So you have your r here. Now this one is still velocity, but this is now under rotational. So this will now be angular velocity. You know this formula, this is how they proved it. Now this is equation 1. Pay attention, please. There's a reason why we are proving it. We'll use it. Now, if this is equation 1, v is equals to r. Now look at what I want to do. I want to differentiate this also with respect to t. So this will now give you the v all over the t is now equals to, what is a constant, r into dw all over dt. Now remember that acceleration is velocity all over time, right? So the whole of this thing is acceleration. Let me come down to this side. So the whole of this place is acceleration. Your r is constant. Your r is constant here. And then this one is your rotational acceleration. And this is equation 2. Now this is how it start getting interesting. This is how it start getting interesting. The linear acceleration, which is that this one is the linear acceleration. A is equals to this. I'm changing this, right? I said this is equation 2. So this linear acceleration is a combination of the tangential acceleration and the radial acceleration. That is an examination question. I said it's a combination of both the tangential acceleration and radial acceleration. So this A is equals to root of A tangential square plus A radial square. This is equation 3. So this linear acceleration is a combination of both tangential acceleration and radial acceleration. Please write it in your notes. We are going to use this thing to solve a lot of stuff. Now, please note this thing. The radial acceleration is the same thing as the centripetal acceleration. And you already know that the formula for calculating centripetal acceleration is v squared all over r. Now, the tangential acceleration is actually this also have radius all over angular acceleration. So this is equation 4, this is equation 5. Now, let's continue. From the radial acceleration, I told you just right now that this radial is something as centripetal, which is central v. So for radial acceleration, you say that this is equal to v squared all over r, right? We are going to have to prove another formula again. Now from this part, recall that from here, from 1, now v is equal to r omega, right? So what I want to do is, wherever I see v here, I will replace it with this. So radial acceleration is now equals to r w square all over r. So this will give you r square w square all over r. So 1 will go into this. So radial acceleration is equals to r w square. Now that's the formula for calculating radial acceleration. R w square or w square all over r, they are still the same thing. Now, please note this. Do you remember from the part 1 of the video, I told you a lot of things about how M is, I is, R is, or the part 1. Please note this. Under linear, kinetic energy is equal to half mv squared. If I want to write it under rotational, this will be kinetic energy will be half your m, which is I, your v is this. So if I want to solve, because there will be a question they will give you the moment of inertia, the angular velocity, and ask you to calculate the kinetic energy. You'll be like wondering, where is my mass? Where is my velocity? Of course, they're talking about rotational form. So here's the formula. I wanted to point it out. Now let's continue with example proper. Enough of this formula proving.